the more you keep up with where you are or where we are in class, the better you're going to do. So you need to be trying to wrap up chapter 4. We're starting chapter 5. And the main reason that I extend those test dates is simply because in case somebody had an emergency or something like that and they were a little bit behind. So that's kind of where you should be. So chapter 5, section 1, this is kind of a longer lesson. Section 2 is not so bad. I originally put that we would cover chapter 5, 1, 2, 3, and 4 this week. I'm thinking it's probably going to be 1, 2, and 3. When I went back and looked at just how long it took to cover this stuff. So 5.1, we're talking about rational expressions and functions. We're going to multiply, divide, and we're going to simplify. So today we need to find all numbers for which a rational expression is not defined or that are not in the domain of a rational function and state the domain of the rational function. Multiply a rational expression by 1, simplify rational expressions, multiply them and divide them and simplify. Okay, so a rational expression is basically just something that you write as a fraction. Okay, so 1/7 is a rational expression because it's a fraction. Z over -6, rational expression, it's a fraction. A over B, 8 over y plus 5, x squared plus 7xy minus 4 over x to the third minus y to the third. We're talking about a fraction. Okay, and it's been a while since we talked about domain, but domain represents your x value. What can x be? Okay. In the equation, what is x allowed to be that it doesn't cause any problem? So it says find the domain of this function, x minus 3 over 2x plus 5. Well, we know that you can't, and we talked about this earlier in the class, but the bottom of a fraction cannot be equal to 0. You cannot divide by 0. So we're going to have a problem whenever anything on the bottom of this fraction is equal to 0. So that's going to be the main place that that x value that makes that 0 is going to be the main place that causes us any trouble. Okay, so I really just need to look at what's going to make that be equal to 0. I need to go, okay, when is 2x plus 5 equal to 0? So we would solve this using algebra, subtract 5 from both sides. We would get 2x is equal to -5, divide by 2, divide by 2, and so these 2's cancel out. So when x is -5 over 2, which if we changed it to a decimal, that would be -2.5. There's a problem, okay? There's a problem right here. This function does not exist right at this place where x is equal to -5 over 2. So it says we must exclude -5 over 2 from the domain. So there's a couple of ways you can write this. You could say the domain of f is equal to x. This line right here means such that all x's, such that x is a real number and x is not -5 over 2. So everything will work. That's what this one says. Everything will work except for -5 over 2. Okay, this one says the exact same thing. It just looks different. It says all the numbers are good from -infinity all the way to -5 over 2, but not including -5 over 2. Then there's a break here, right? Then start it up again at -5 over 2 to infinity. So this one place, -5 over 2, is a break. There's a break there. And these two statements mean the same thing. We're going to talk about this some more. Okay. So this says find all the numbers for which the rational expression 3x plus 5 over x minus 5 is not defined. Well, we're worried about the bottom of this fraction because it cannot be equal to 0. So what's going to make the bottom of that fraction equal to 0? We would have to add 7. So when x is 7, we have a problem. because 7 minus 7 is 0, and the bottom of the fraction cannot be equal to 0. So this function is good for every other number except for 7. So this irrational expression is not defined for the replacement x equals 7. Okay, they wrote this two other ways before, and I want to write those for you here. Okay, remember they had a statement that was like the domain, this stuff right here, the domain of f. So this one, if this is the case, we would say the domain of f is equal to all the x's such that x is a real number and x is not 7. That's the place that we have a problem. The other way to write this is we're good from negative infinity to 7, but not equal to 7, and then join that with we're good starting at anything bigger than 7 to infinity. These two things, this and this, say the exact same thing. It's just different notation. We got to split at 7. Okay, on this one it says find all numbers for which the rational expression is not defined. Well, we know we have a problem if we have a denominator of the fraction and it is equal to 0. It can't be equal to 0. So what makes that x let this be equal to 0? We'll subtract 3 from both sides. So x, when x is equal to negative 3, we have a problem. So our domain is all x's such that x is a real number and x is not negative 3. Let me see if I can get that to fit a little bit better. I don't know why I keep doing that. Okay. We could also write that as we're good from negative infinity up to negative 3, but negative 3 causes us a problem. After negative 3, we're good again to positive infinity. It's the same way of writing. The same, those two things mean the exact same thing. We've got a problem in our domain if the bottom of the fraction is equal to 0. Okay, there's going to be one other time we have a problem in our domain. It's when we have a square root, but we're not having to deal with that in this lesson. So we're just kind of taking this one thing at a time. So we spent a lot of time in chapter 4 working on problems like this. Okay, and so once again, we're focusing just on the domain, and we know that we're going to have a problem when this thing right here, x squared plus x minus 6 is equal to 0. So that's what I'm kind of looking for. When is x squared plus x minus 6 equal to 0? During chapter 4, we would factor that. We would say, well, what multiplies to negative 6? What multiplies to negative 6 and adds to 1? And we would come up with those two numbers. Well, they would be positive 3 and negative 2, which is why they have positive 3 right here. And so we would put x minus 2 right there. Once again, chapter 4 goes over how to do that a whole bunch. So once we get to that point, we want to solve it and figure out, well, where are the problems? Well, they went ahead and said x plus 3 is equal to 0. Subtract 3. And so that's how they came up with x is equal to negative 3 is a problem. The other one would be x minus 2 equals 0 is a problem. So you would add 2 to both sides. And we would get that x equals 2 is a problem. So this expression is not defined for the replacements -3 and 2, which means that the domain is all real numbers and x is not equal to -3 and x is not equal to 2. And when you do this statement, since we had two numbers, right, we had a -3 and a 2, you always list them in order. So we're good from -infinity up to -3. We're good from the numbers in between -3 and 2 are good. And then from 2 to infinity, right? That's how you would divide that up if you were to write it this way. Okay, so find the domain of G of X. Now, we're focusing on the bottom here. So we're trying to factor this. We want to know, well, when is that equal to 0? So we're wanting something that multiplies to -4, multiplies to -4, but adds to 3. 4 times -1. 4 times -1 is -4. 4 plus -1 is 3. So those are my two numbers, 4 and -1. So x minus 4, I'm sorry, x plus 4, +4, and -1, and x minus 1 are going to be my two trouble places. So we're going to want to solve this and say, well, when is x plus 4 equal to 0? And when is x minus 1 equal to 0? So we're getting x is equal to -4. We add 1. X is equal to 1. So these are my two trouble areas. So when I want to write the domain, it's all x's, such that x is a real number but x is not equal to -4 and 1. You could put and x is not equal to 1 as well. The other way to write that would be that we're good from -infinity to whichever one of these two comes first on the number line. So we're good to -infinity to -4, but not at -4. Then we can pick it up again. All the numbers in between -4 all the way up to 1 are fine. And then from 1 to infinity, all of those are fine. Okay, that's how we would split that up. So you just can't have the bottom of the fraction equal to 0. Causes a problem in your domain. Questions about anything? Okay. So to multiply rational expressions, multiply numerators and multiply denominators. Okay, so what they're trying to get you to see that is if you have this exact same thing on the top and the bottom, that they equal 1. So 73 divided by 73 is 1. X minus y over x minus y is 1. 4x squared minus 5 over 4x squared minus 5 is 1, because they're the exact same thing on the top and the bottom. Okay. And what happens when you multiply something by 1? You just get back what you started with. So that's a legal step. Okay, so to simplify a rational expression, we remove factors that are equal to 1 and simplify by removing a factor equal to 1. So what does this mean? They looked at this 2x squared plus 6x, and they were like, can I factor anything out of the top of that? I've got a 2 and a 6, so they were like, I can pull a 2 out of both of those terms. I've got an x squared and just a regular old x, so all the x's I could take out would just be the 1. So they took a 2x out of all this stuff. So if they take a 2x out of 2x squared, they're just left with x. If they take a 2x out of 6x, well, 6 divided by 2 is going to give you 3, and then they pulled that x out. And on the bottom here, they've got 2x to the third, and they just kind of split this up. Now, here's what I'm saying to you. I would not go through all these steps to work this. I would have done that first step that they did and say, pull out a 2x from both terms, and then on the bottom I would have a 2x to the third, okay? And if all of these steps make sense to you, that's great. You can do that way. But what I would have immediately done here is I would have said, look, I could cancel out a 2 and a 2. Those 2's are going to go away because that would make a 1. Okay, I've got this x right here, and I've got 3 of them down here. So if I take away 1 out of that group, I still would have an x squared left. Right, if I cancel this x out with this one, I would still, this is 1 and this is 3, I would still have an x squared left. Well, then I would be ready to write my answer. And I don't really need the parentheses on the top. I would just have x plus 3 over x squared. A lot of people want to try to cancel out an x right here. Why can't I do that? This one has a plus sign in between it. It's not the same as this other one when you're multiplying. We'll work other examples like that, but you're done. You have to be multiplying in order to be able to cancel out. So let's look at this one. First thing, focus on the numbers, right? So the 5 and the 30. Can I reduce that fraction? Yeah, we can divide them both by 5, right? So I could divide the top by 5. I could divide the bottom by 5. That would get me 1 over 6. Are we okay with that? Then I've got my variables. I've got an x, y on the top, and I've got an x on the bottom. Well, this x should cancel out with this x. They're exactly the same, which is, pardon me, which is just going to leave me with 1, 6y. That could be written as just y over 6. Some people might pull the 1, 6 out front and put the y like that. All 3 of those would be the exact same answer that I'm left with. Okay, if I focus on just the number part first, we've got 12 over 4. Well, 12 divided by 4 is just 3, right? I've got 12 divided by 4 is just 3. So then if I add the rest of the stuff, I've got 3p, I already took care of the 4, and then I've got a y and a p. Right, so the p's would cancel out, and I would just have 3 over y as my final answer. Factored everything out. Okay. On this one, this is a little bit different. I'm going to leave this 10 alone for right now. But on the top, I've got this subtraction. So this makes it a little bit more difficult. But is there anything that 4 and 20 have in common? The biggest thing that 4 and 20 have in common? 4 will go into both of those numbers. I can't pull out any x's out of both of them because the 20 doesn't have any x's. I can pull out a 4. So 4 divided by 4 is 1, and then I still have this x left. Okay, and then I've got negative 20. Well, negative 20 divided by 4 would be negative 5 or minus 5. So I took care of that. Now I want to really focus on this number in front, this 4/10. Can I reduce 4/10? Yeah, because I can divide them both by 2, right? So 4/10 is really just 2 over 5. And then I've got x minus 5 in parentheses. Okay, I could multiply this back out if I wanted to and say, well, that's 2x minus 10 over 5. But these two things, these two statements are exactly the same. Just depends on how they want you to write your answer. Questions about that stuff? So I'm looking at this, I'm going, okay, this one, the only number on this one is really just a 1. So I'm not going to worry about the 1 and the 4 because I can't really factor anything out of that. But they both have, this one has an x squared and this one has an x. So I could at least pull an x out of both of those. If I take an x out of x squared, that just leaves me with x to the first, right? If I take an x and I pull it out of x squared, I'm just left with x to the first. If I take an x out of 4x, I'm going to have a plus 4. And then there's really not anything I can do with the 5x. Now we can cancel out now this x and this x because x over x is just 1. And what we would have left is our x plus 4 over 5 that we didn't have anything that would cancel out with. Still okay? Cameron, you too? Okay. Canceling is a shortcut often used for removing a factor equal to 1, which we just did a lot of that of, okay? So it's got an example of a rational problem that has been worked out for you. So when you look at this, they've taken 3x squared plus 13x minus 10, and they factored it. They also factored the bottom, and they noticed that when they factored it, they had something that was the same. The 3x minus 2 and the 3x minus 2 were both the same. So they could mark those out because that just turns into 1. And all you're left with is x plus 5 over x plus 7 when everything else, those other two things cancel out. Okay, and there is some examples of some things to not do. We talked about this one. You can't, if it's x plus 7 over x, you can't cancel out the x's because this thing in the middle has to be a multiplication. It can't be a plus. Same thing here. If we've got 5x minus 2 over 15, well, because this is not 5 times this whole thing, we can't cancel it out. It's connected to this minus 2. Same thing here. This 3 is not multiplied, it's being subtracted, so we can't cancel that out. So those are just some examples of what not to do. Sometimes it makes it worse when you show people that, but okay. X squared minus 9. Now, please feel free to stop me, but I'm not, unless if you're confused about something, I will definitely stop. But we've already gone over the factoring part of this. So I'm not going to go back and teach the factoring part unless you have a question about it. I'm just going to go straight forward to factoring. So x squared minus 9 is the difference of squares, okay? And we did this in chapter 4. So I know that x squared minus 9 is really x minus 3 times x plus 3. Okay, x squared plus 2x minus 3. I'm looking for something that multiplies to negative 3 but adds to 2. So that's going to be x plus 3, right, and x minus 1. Okay. If you're still stuck on the factoring thing, make sure you want to finish chapter 4 before you really get into this because you need to be able to factor. Okay, since I know that, I'm seeing two things that are the same. I'm seeing the x plus 3s that are the same, so these x plus 3s can cancel out. They turn into 1, and my final answer is x minus 3 over x minus 1. Okay, same thing here. I'm looking for two numbers that multiply to negative 8, but add to negative 2. Okay, so something that multiplies to negative 8 but adds to negative 2. So x minus 4, x plus 2. Negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. On the bottom, I'm looking for something that multiplies to 20 but adds to negative 9. So -4 and -5. -4 times -5 is 20. -4 plus -5 is a -9. Okay, the goal here is that we would like to have something that cancels out. And we do because we have 2x minus 4. So our final answer would be x plus 2 over x minus 5. Trying to get something that can cancel out. Okay, on this one. I don't think there's a lot I can do to the bottom, but if I can pull an A out of both of these terms, then I could get that A on the bottom to cancel out. So that kind of makes sense. I need to try to pull an A out of both of these terms. If I take an A out of 3A squared, I would just have a 3A. If I take an A out of A, okay, this is important. This is probably where people make a mistake. If I take this A out of this A, right, I still have something. It's a 1 because A divided by A is 1. Can't not put that. So 3A minus 1. Now you can see that we've got A and A on the top and bottom, so that the final answer is 3A minus 1. Okay, this is the same type of situation over here. Can't really change that Y that's on the top, but I can, if I can pull a Y out of the bottom, if I take a Y out of Y squared, I still have a Y. If I take a Y out of minus 3Y, I have minus 3. Well, that's going to make this Y cancel out with this Y. On the bottom, I would have Y minus 3. The number one mistake people make on this problem is they think everything canceled out on the top, so the answer is just Y minus 3. But you've got to put something there. And it's going to be a 1. When everything cancels out, there's still that 1 there, because that's the whole point of things canceling out. They turn into 1. Questions? Okay. This one is weird, but if you look at it, it's almost like they're opposites of each other, right? One of them is P minus 7 and the other 7 minus P. So when you see this, we can get something to cancel out if we take and pull out a negative out of one of them. So you remove a negative. When you take a negative out of something, it makes everything be opposite of whatever it was. So in other words, if this was a positive P, it becomes negative P. If this is a negative 7, it becomes positive 7, because negative means the opposites, right? So I can pull out a negative out of this, and this is what I get, opposite of what I had before. And why that matters is because now we have 7 minus P on the bottom, but can I write that bottom? Can I move the negative P in the front and the positive 7 in the back so that they'll match? Because they're the exact same thing. So that negative P plus 7 and negative P plus 7 cancel out. They turn into 1. I'm left with a negative. The answer is negative what? Going to be a 1 there. If everything canceled out except for that negative sign, I still have a 1 to hold that place. So this thing was negative 1. I pulled out it. I noticed that they were backwards. That was the first thing. And then I knew, okay, if they're backwards, pull out a negative and you should be able to get it to cancel out. These are close. These are backwards too, right? Looks to me like I'd probably want to pull the negative out of the bottom one, which would make that be a Y. So if it was a negative Y, it'll become a positive Y. If it's a negative 3, it'll become a positive 3. And I already have Y plus 3 on the top, so this cancels out with this. I'm just left with this negative on the bottom of a fraction, which means the answer is what? Negative 1. Because those canceled out, they turn into 1. Most of the time when there's other numbers there, we don't put the 1, right? But if there's nothing left, we have to put the 1 when they cancel out. Okay? Questions? Hey, y'all are doing awesome. Okay, multiplying and simplifying. So when you multiply straight across. And the other advice I would give you is make sure, I like to try to simplify before I multiply. For instance, if I can notice anything has something that will cancel out before I multiply, it makes my life a lot easier. For instance, I see this 5 right here, and I see this 20 on the bottom. And 5 and 20 have a 5 in common. I could divide this 5 by 5 and get 1. I could divide this 20 by 5 and get 4. If I do that, it'll make it where it's easier for me in the end. Now, the other numbers I have on the top, y minus 3, well, that's not really going to cancel out with a 2 or a 4, so that's pretty much it. Then you would multiply straight across. So 1 times y minus 3 over 2 times 4, which would give me 8. Most people would not write the 1 down. They would just leave it like this. Okay, what about the 8 and the 4? They have anything in common? I can divide an 8 and a 4 both by 4, right? So 8 divided by 4 is 2. 4 divided by 4 is 1. Okay, anything else have anything in common? I've got an X and an X. Those can cancel out, right? I wouldn't have anything left with those because they're exactly the same. Okay, the 2 and the 3, nothing. X plus 3 doesn't have anything in common with either of these on the bottom. So you're going to do 2 times X plus 3 over 3 times 1, which is just 3. Okay, and this down here says we leave the answer in factored form. In other words, you don't have to distribute this. You can just leave your answer 2 times X plus 3 over 3. Unless it asks you to multiply it back out, you're good. Just leave it like that. Questions about that? Okay, told you this was a long one. Okay, we have 2 pages left and they're not as difficult, but so multiply and simplify. Now these two do look like they're complicated. So where are we even going to start? I think we're going to have to factor first, right? We're going to have to look at each part and see if we can factor anything out, because if you go ahead and multiply, you're going to have a lot more work in the end. So I'm focusing on this x to the third plus 5x squared. And when I look at that, I can see that I could take an x squared out of both of those terms. So if I take an x squared out of x to the third, I have an x left. If I take an x squared out of minus 5x squared, I would have a minus 5 left. Okay, so I pulled x squared out of both of those terms. This one looks like a quadratic, like we've been factoring in chapter 4. So I know that I'm probably going to have to do this number where I have 2 parentheses. Say, well, what multiplies to -2 but adds to -1? -2 plus 1, right? 1 times -2 is -2. 1 plus -2 is -1. So there's that. Then we're going to focus on the bottom. So same thing here. I need something that multiplies to 5 and adds to 6. That's not bad. X plus 1, x plus 5. 5 times 1 is 5, but 5 plus 1 is 6. Okay. Looks to me like this one's a little bit different. This is x to the third minus 25x. I could pull an x out of both of those. Okay, if I take an x out of x to the third, that's just going to get me x squared. If I take an x out of minus 25x, I've got minus 25. Now, we have to be careful in the fact that we've got to be able to recognize some of the things we already learned, and this thing right here is special. This is a difference of squares, right? X squared minus 25. So this actually will change into, I'm just going to put my X from here down again. But when it's the difference of squares, it's separated by a minus. X minus 5, X plus 5. I could keep going with that one, because it's the difference of squares. I think we did that in one of the very last sections of chapter 4. Okay, now I'm going to just mark out through this so I don't pay attention to it. If there's anything that is exactly the same on the top and the bottom, they can cancel out. Okay, so I'm noticing that I've got an X plus 1 down here and I've got an X plus 1 up here. Those can turn into 1. I'm noticing that I have an X minus 5 up here and an X minus 5 down here, so those could cancel. I don't see anything to go with my X minus 2. I don't see anything to go with my X plus 5, so I've got 2 of those. This X right here, though, can cancel with one of these X squareds, and I would be left with X on the top. One of this X would took away one of these X squared, so I've got X on the top. So on the top, I've got an X. Everything else has been marked through except for X minus 2. And on the bottom, I've got X plus 5 times X plus 5. Most people will probably write, since they're the same, they would probably say X plus 5 squared. If it was a test or something like that. Okay, turned it up a notch, right? This is a little bit more difficult. Kind of pulling everything together. So we know that we've got to factor this stuff out. So we need something that multiplies to negative 40 but adds to negative 3. Is it negative 8 and 5? So X plus 5, X minus 8. Negative 8 times 5 is negative 40. Negative 8 plus 5 is negative 3. Something that multiplies to negative 3 but adds to negative 2. So X minus 3, X plus 1. X squared minus 9, that's a difference of squares, right? So that just means it's X minus 3, X plus 3. X squared minus 25, difference of squares, X minus 5, X plus 5. Anything that is the same that's on the top and the bottom get to cancel out. So I see an X plus 5 up here and I see an X plus 5 down here. I don't see anything to go with my X minus 8. I see an X minus 3 up here and one down here. I do not see anything to go with my X plus 1 on the bottom. So that's it, right? We're left with X minus 8 times X plus 1. X plus 3 times X minus 5. We're left with those things. We couldn't get them to cancel out. So we've got a short explanation of division here. Remember that when you're dividing, okay, they wrote the problem down again right here. They changed the division to a multiplication in this example, and then they flipped the second number. That's the only difference when you're dividing. You change the division to the multiplication and you flip the second number, and then you can get your stuff to cancel out. Okay, so let's look at the division problems. This is it. So if I want to write this as a division, I want to turn my division to a multiplication, take my second fraction and flip it. Turn my division to a multiplication, take my second fraction and flip it. Now we could have reduced before we did that, but there really is not a reason to do that. So the only section that I see that I can pull anything out is this top. I see that both of these have an X in them. So I could actually pull an X out of that. That would leave me with X plus 3. But the rest of the stuff doesn't really have anything that you can separate out on this one. So do I have any X plus 3s on the bottom that are going to cancel out? No. I don't have any X plus 2s that are going to cancel out. I do notice that I have this X right here would cancel out with this X right here. These two cancel out. And that's it. So I'm left with X plus 3 times X plus 2 over X minus 1 times 5. I almost forgot about my 5. Hardly anything canceled out of that one. Okay, we've got X plus 2 over X minus 5. I'm going to change my division to a multiplication. I'm flipping my second fraction. I don't think anything's going to factor out of X plus 2 or X minus 5. I do notice that there's a 2 in both of these terms. If I take a 2 out, that's going to get me, if I take a 2 out of 2x, I'm just going to have x. If I take a 2 out of negative 10, I'm going to have negative 5. And I got a 5x on the bottom. Well, that helped a little bit because at least this x minus 5 cancels out with this x minus 5. So on the top, I would have 2 times x plus 2 over 5x, but nothing else is going to go on that one. Okay. So we have x squared minus 3x minus 10 over x plus 5. Change the division to multiplication. Flip the second fraction. Okay, so we need something that's going to multiply to negative 10, but add to negative 3. Negative 5 and positive 2, x minus 5. So negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. Okay. We need something that's going to multiply to negative 5 and add to 4. So x plus 5, x minus 1. 5 times negative 1, negative 5. 5 plus negative 1, 4. We want to pull something out of it. I think I could take an x out of both of those. So we would have x plus 2 left. Do y'all understand where I'm coming up with this stuff? So I will stop and go back. Okay. So then you want to see if anything's the same on the top or the bottom that will cancel out. I'm noticing that I don't have anything to go with this x minus 5. X plus 2, x plus 2. X plus 5, x plus 5, nothing to go with x minus 1. So it looks like I'm left with x minus 5 times x minus 1 on the top of that fraction, and on the bottom, all I have left is an x. Okay. One last problem. X squared plus x minus 6 over x plus 1. Division turns to multiplication. We flip that second fraction. Okay, so we need something that multiplies to negative 6, but adds to 1. x plus 3, x minus 2, because 3 times negative 2 is negative 6. 3 plus negative 2 would give us our positive 1 here. Something that multiplies to 3 and adds to 4, that's going to be 3 and 1. This is special because it's the difference of squares, right? When you see 2, you're looking for 2 things that are subtracted that are perfect squares. When that happens, x minus 2, x plus 2. Take the square root of those numbers, and one time you add them, the second time you subtract them. There's nothing to go with my x plus 3 on the bottom. And x minus 2, yeah. X plus 1, yes. But that's it, right? So we've got our final answer, x plus 3 times x plus 3. And on the bottom, we end up with an x plus 2. And that is the end of 5.1.